Electrical metallic tubing, commonly known as EMT conduit, can be run through an elevator mechanical room, provided it has absolutely nothing to do with the elevator's operation or control systems. This allowance hinges on the principle that the electrical systems serving general building needs should be physically and functionally segregated from the specialized electrical systems dedicated to the elevator. The National Electrical Code, or NEC, provides specific guidelines for electrical installations in and around elevators, emphasizing safety and reliability. Firstly, it's crucial to understand the purpose of the elevator mechanical room. This room typically houses the machinery responsible for moving the elevator car, including motors, controllers, and related electrical equipment. Because of the critical nature of these systems and the potential hazards associated with them, the NEC imposes stringent requirements for wiring methods and equipment used within the space. Secondly, the NEC addresses the separation of elevator-related circuits from general building circuits. This separation aims to prevent faults in the general electrical system from affecting the elevator's operation, which could lead to safety issues for passengers. Therefore, any EMT conduit passing through the elevator mechanical room must serve circuits unrelated to the elevator's power, control, signaling, or communication systems. Thirdly, even if the EMT conduit is unrelated to the elevator, it must still comply with all applicable NEC requirements for wiring methods in general building areas. This includes proper support and securing of the conduit, appropriate conductor fill, and protection against physical damage. The conduit must be installed in a neat and workmanlike manner, following industry best practices. Furthermore, the conductors within the EMT conduit must be properly insulated and rated for the voltage and current they will carry. Grounding is also essential to ensure electrical safety and prevent shock hazards. One should use the correct fittings and connectors for the EMT conduit to maintain a continuous ground path throughout the system. It's also important to consider the environmental conditions within the elevator mechanical room. These rooms may be subject to temperature variations, humidity, and the presence of dust or other contaminants. The EMT conduit and associated fittings must be suitable for these conditions to ensure long-term reliability and prevent corrosion or other forms of degradation. When planning an EMT conduit installation through an elevator mechanical room, it is a good practice to consult with a qualified electrical engineer or a licensed electrician. These professionals can assess the specific conditions of the installation and ensure compliance with all applicable codes and standards. They can also help identify any potential hazards or challenges that may need to be addressed. Another consideration is the potential for future changes or modifications to the elevator system. If the EMT conduit is installed in a location that could interfere with future elevator maintenance or upgrades, it may need to be relocated or rerouted. Therefore, it's important to coordinate with the elevator maintenance personnel to ensure that the conduit installation does not create any conflicts. The NEC addresses specific requirements for elevator electrical systems in Article 620. This article covers various aspects of elevator wiring, including power, control, and safety circuits. While Article 620 primarily focuses on elevator-related systems, it also provides general guidance on wiring methods and safety practices that are applicable to all electrical installations in and around elevators. One should review Article 620 carefully to ensure a complete understanding of the requirements for electrical installations in elevator mechanical rooms. In addition to the NEC, local building codes may also impose specific requirements for electrical installations in elevators. These local codes may be more stringent than the NEC in some areas, so it's important to check with the local authorities to ensure compliance with all applicable regulations. Permit requirements should also be researched prior to beginning any electrical work. Many jurisdictions require permits for electrical installations, including conduit runs. Obtaining the necessary permits ensures that the work is inspected and approved by the local authorities, which helps to ensure safety and compliance. Regarding the installation of EMT conduit, one must adhere to the requirements outlined in Article 358 of the NEC. This article provides detailed information on the proper installation methods for EMT, including support, securing, and bending. The NEC specifies the maximum spacing between supports for EMT conduit to prevent sagging and ensure that the conduit is properly supported. The spacing requirements vary depending on the size of the conduit and the type of support used. Proper bending of EMT conduit is also essential to ensure that the conduit maintains its structural integrity and that the conductors within the conduit are not damaged. The NEC specifies the minimum bending radius for EMT conduit to prevent kinking or flattening of the conduit during bending. One should use the correct bending tools and techniques to achieve the desired bend without damaging the conduit. When connecting EMT conduit to boxes or enclosures, it is important to use the correct fittings and connectors. The fittings must be properly sized for the conduit and must provide a secure and watertight connection. Lock mats and bushings should be used to ensure that the conduit is properly grounded and that the conductors are protected from abrasion. Grounding is a critical aspect of electrical safety, and it is essential to ensure that all electrical systems are properly grounded. The grounding requirements for EMT conduit are outlined in Article 250 of the NEC. This article provides detailed information on the proper methods for grounding electrical systems, including the use of grounding conductors, grounding electrodes, and bonding jumpers. One should adhere to these requirements carefully to ensure that the electrical system is properly grounded and that the risk of electrical shock is minimized. In summary, running EMT conduit through an elevator mechanical room is permissible as long as it serves circuits unrelated to the elevator, adheres to all applicable NEC requirements, and is installed in a safe and workmanlike manner. Consulting with a qualified electrical professional and obtaining the necessary permits are essential steps to ensure compliance and safety. The NEC emphasis on separating elevator-related circuits from general building circuits is a key principle to follow. This separation aims to prevent faults in the general electrical system from affecting the elevator's operation, which could compromise passenger safety. Therefore, it is crucial to maintain this separation when installing EMT conduit in an elevator mechanical room. Even if the EMT conduit is unrelated to the elevator, it must still comply with all other applicable NEC requirements for wiring methods in general building areas. This includes proper support, securing, conductor fill, and protection against physical damage. Ignoring these requirements can lead to safety hazards and code violations. In addition to the technical requirements, one should also consider the aesthetic aspects of the EMT conduit installation. The conduit should be installed in a neat and orderly manner, and it should not obstruct access to other equipment or create tripping hazards. Good workmanship is essential to ensure that the installation is both safe and visually appealing. When working in an elevator mechanical room, one should be aware of the potential hazards present in the environment. These hazards may include exposed electrical conductors, moving machinery, and slippery surfaces. One should take appropriate precautions to protect themselves from these hazards, such as wearing appropriate personal protective equipment and following lockout/tagout procedures. The NEC requires that all electrical work be performed by qualified individuals who have the necessary training and experience. This requirement is intended to ensure that electrical work is performed safely and in accordance with applicable codes and standards. One should never attempt to perform electrical work unless they are properly qualified to do so. Furthermore, it is important to maintain accurate documentation of all electrical work performed in an elevator mechanical room. This documentation should include detailed drawings, wiring diagrams, and equipment specifications. Accurate documentation is essential for troubleshooting and maintenance purposes, and it can also be helpful in the event of an emergency. The NEC is a constantly evolving document, and it is updated every 3 years to reflect changes in technology and industry best practices. It is important to stay up to date on the latest edition of the NEC to ensure that electrical installations are in compliance with the most current requirements. Continuing education courses and professional development activities can help electricians and electrical engineers stay informed about the latest changes to the NEC. The use of appropriate tools and equipment is essential for performing electrical work safely and efficiently. One should use only tools and equipment that are in good working order and that are properly rated for the voltage and current levels involved. Defective or improperly rated tools and equipment can pose a significant safety hazard. Regular inspections and maintenance of electrical systems are essential for ensuring their continued safety and reliability. One should perform regular inspections of EMT conduit installations to identify any signs of damage, corrosion, or loose connections. Any issues identified during inspection should be promptly addressed to prevent further deterioration and potential safety hazards. In addition to visual inspections, electrical testing should also be performed on a regular basis to verify the integrity of the electrical system. Electrical testing can help identify hidden problems that may not be apparent during visual inspections. The results of electrical testing should be documented and used to track the performance of the electrical system over time. When making any modifications to an existing electrical system, it is important to ensure that the modifications are properly integrated with the existing system. Modifications should be performed in accordance with applicable codes and standards, and they should not compromise the safety or reliability of the existing system. Before making any modifications, one should carefully evaluate the potential impact of the modifications on the existing system and take steps to mitigate any potential risks. The NEC provides specific requirements for electrical installations in hazardous locations. An elevator mechanical room may be considered a hazardous location if it contains flammable gases, vapors, or dust. If an elevator mechanical room is classified as a hazardous location, one must comply with the additional requirements outlined in Article 500 of the NEC. These requirements include the use of explosion-proof equipment and wiring methods. Coordination with other trades is essential when performing electrical work in an elevator mechanical room. Electrical work may need to be coordinated with the work of other trades such as mechanical, plumbing, and fire protection. Effective communication and coordination can help prevent conflicts and ensure that the work is completed safely and efficiently. The NEC requires that all electrical equipment be properly labeled to identify its function and voltage rating. Proper labeling is essential for troubleshooting and maintenance purposes, and it can also help prevent accidental contact with energized equipment. One should ensure that all electrical equipment in an elevator mechanical room is properly labeled. The use of surge protective devices, or SPDs, can help protect electrical equipment from damage caused by voltage surges. SPD should be installed at the service entrance and at other critical locations throughout the electrical system. The NEC provides specific requirements for the installation of SPD. The NEC requires that all electrical enclosures be properly secured to prevent unauthorized access. Enclosures should be equipped with locks or other security devices to prevent tampering and to protect against accidental contact with energized equipment. In the context of elevator mechanical rooms, security is crucial due to the sensitive nature of the equipment and the potential for unauthorized access to disrupt elevator operation. The NEC provides guidance on the selection and installation of overcurrent protective devices, such as circuit breakers and fuses. Overcurrent protective devices are designed to protect electrical circuits from damage caused by excessive current flow. One should select overcurrent protective devices that are properly rated for the circuits they are protecting. The NEC requires that all electrical splices and terminations be made in a safe and reliable manner. Splices and terminations should be made using approved connectors and methods. Improperly made splices and terminations can lead to overheating, arcing, and electrical fires. The NEC provides specific requirements for the installation of fire-stopping materials and electrical penetrations. Fire-stopping materials are designed to prevent the spread of fire through openings in walls, floors, and ceilings. One should use approved fire-stopping materials and methods when installing EMT conduit through fire-rated walls or floors. In conclusion, while running EMT conduit through an elevator mechanical room is permissible under specific conditions, it necessitates a thorough understanding of the NEC, local building codes, and best practices for electrical installations. Prioritizing safety, compliance, and coordination with other trades ensures a reliable and hazard-free electrical system. Always consult with qualified professionals and obtain necessary permits before undertaking such project.